Hey guys, in this video I am going to be talking about three different types of password scripts that you can create in Python, and I will be talking about three different levels of Python scripts that you can create. The first one, I like to call it the noob script because even a complete noob to Python can create it, but it's also not very secure. The second one is a little bit more advanced. It will take a little bit more time to develop, and the third one takes a bit of time to develop, but it is almost unbreakable, as unbreakable as an encryption that you can create at home could be. So without further ado, I'm going to get started on the first script. If we go ahead and run the code, we can see that it prompts us for a password. The password is obviously like. It says unlock successful. If we run it again, this time we give it the incorrect password, maybe dislike. It'll say it's an incorrect password and that we should try again. So this is very, very simple. But unfortunately, that simplicity makes it easy to hack. So for example, all we have to do is just go in here and see that the variable user password is set to like, and that there is a function that says compare those passwords. Compare correct password with that variable. And then we can see that down here, it's called with the user password variable. So all we have to do is just take this value here, go ahead and copy it. We're going to go ahead and paste it back in. Oops, we're going to go ahead and run the code. We're going to paste that in there. And just going to say it's unlocked. So moving on to the second, slightly more complex password script. can see, we have two scripts here, an ASCII convert script and the harder password script. Let's start with the ASCII convert script. So basically, it's simple. You run it. And then you enter a phrase to convert to ASCII. Let's just do, I don't know, test. As you can see, it returns the ASCII values. So the way it works is simple. First, it gets an input variable and sets it to the input of the user. There's only one function, the encrypt function, which gets the parameter message. And then basically all it does is it goes through every letter in message and then it adds the ASCII value of that letter to a variable called encrypted string. It also adds a space after every value to make it readable. And then it returns that string, and then down here the function gets called and it prints it. Pretty simple stuff. So what you do now is you take that value and you put it in here. In this case, I've actually set the value to subscribe. So now you have your encrypted password and you have your user input. Then we have three functions, the encrypt password function, the compared password function, and the main function. The compare passwords function and the main function. So these are all pretty self-explanatory. So let me explain the order that these things are called. First, you set the variable encrypted input equal to the output of the encrypt password function. By the way, I just took that function and copy pasted it from the ASCII convert script because it does literally the exact same thing. So what it does is it takes the input, converts it to ASCII, and then it uses the compare passwords function to compare it with the encrypted password. And if it's correct, it runs the main function. If it's not, it sends you a message. Let's run it. Crap. Let's run it. Cool. Wants a password, subscribe, and access is granted. If it's incorrect, like not subscribed, it tells us to try again. So cracking this one is going to be slightly more complex. There's two ways you can do this. So we can try to reverse engineer the ASCII function, or we can just grab our encrypted password, go into our web browser, and we can look up to an ASCII to text converter. Go ahead and put that in, paste it, convert it. There you go, there's our password. Just grab that, come back here, run the code, and then paste it in. And there we go, this is cracked. So this is obviously slightly more secure than our other script because it does not store the password in plain text, but it's still pretty easy to figure out exactly how it was encrypted. What if there was a method for storing passwords that was more secure than encryption? Well, in my next password script, which actually is very similar to the industry standards for storing personal data. That was a lot of coding. And you'll notice that I have had to create 3 scripts. This first one is called hash tester. And a majority of this code I just copy pasted from geeksforgeeks.org. Actually, they have a very interesting website about hashing in Python, which I will link to in the description if you're interested. So go check that out. What this script does is it imports the hashlib library, which is a Python library that creates hashes. If you don't know what hashes are, I'm not going to go into super detail right now, but basically it's where a computer will take a human readable string, like this one here, and it will perform a series of mathematical operations on it that turn it into this gobbledygook that almost nobody can read. Now, this process, by the way, is completely irreversible. And if you're wondering why this is useful, I will show you in a minute. And then it just prints it out in 2 different formats. Prints out the raw digest of the hash, and then it prints out the hexadecimal equivalent of the hash here. But that's not really important. We are going to check out the next piece of code I wrote called string hasher. What this does, again, it imports the hash library, sets an input variable equal to an input from the user, and then runs this hash string function, which will take the hash, run this hash string function, which will set a variable called result equal to the hash of the input. And then it'll return the hex address of that result and then print it out down here. If we run this, it says enter string to be hashed. We enter our string, and it returns the hash. It's that simple. This is our password script. While it may not look like too much under the hood, there's actually some pretty complex code here. It starts like before, or it starts like all of my other hashing scripts by importing the hashlib library. Then we have a variable called password hash, which is the hash that we get from our string hasher program. By the way, I only went ahead and wrote the password down because I knew I'd forget it if I didn't. And then it has a variable for user input here, which is just asking the user for input. Then it has a function called hash input, which I just copied from string hasher and pasted into here. Then it has, just like the other programs, a compare passwords function and a main function. And then here it just hashes the input password with that hash input function, and then we'll feed it into this compare passwords function. And if that result equals 1, it'll run main. If it doesn't, it won't run main, and it'll send an error message. So the big deal about hashing and why this is so good is because there is no way for you to recover anything from a hash easily, except by brute force. So, but if you hash the exact same string, it'll return the exact same result. So by hashing the input password and then comparing it with the correct password hash, it can tell whether or not the correct password is entered. Watch. If we enter the correct password, which is comment, it'll say access granted. If we enter an incorrect password, it will tell us that we have the wrong password. So, as I mentioned before, so how are we going to break this code? Well, that's where things get interesting. See, cracking hashes, it seems simple, but it's really not. So, as you know by now, I'm sure. So, as I've told you, if you hash the same string twice, it'll give you the same input no matter what. So, there are 2 main ways to crack them. You can use what's called a dictionary attack, which is where you get, say, a list of common passwords, like top 1,000 most common passwords. And then it will run each of them and then it'll run a compare, and then it will compare them and see if it finds a match. If it does, then that's what the hash is equal to. There's also a brute force method, which just uses raw computing power to generate as many possible random hashes as it can, and it will see if it can get it will see if I can get a hit. The dictionary attack method only works with common weak passwords. Like comment, I'm sure is not a highly common password, but if we were to set this to, say, password, we might have a shot at it. In fact, I'm going to start building a brute force script now. Alrighty, I finally have the script done. Unfortunately, there is no coding montage this time, so I'm sorry if I disappointed you, but this script, for whatever reason, was being very finicky, and I was going to have over an hour's worth of footage to edit if I left it rolling the whole time. So I didn't really feel like making you sit through a very long coding montage, and I really didn't feel like editing a very long coding montage. So there we go. Alright, this script, just like the other one, starts by importing hashlib. Then we have a list here called guesses, which is the 100 most common user, which is the most then we have a list here called Guesses, which is the 100 most common passwords on the internet. I'll link the Wikipedia article where I got those in the description as well. And then we have here a line that asks for the user's input. And then we have our hash string function. And then we just have a for loop, which for I in guesses will run the hash string function and compare it with the user's generated hash. And once it finds it, it'll print the password and it'll break. And it'll exit. Once it finds it, it'll print the password and exit the code. And come on, VS Code. As you can see, the code works. Let's test it out on our hash that we can recover from our password script. Copy that. Run the code. Paste it in. And it returns password here. Copy it. And then let's go ahead and run this code. Paste it in. There we go. This should be a lesson as to why you need to use difficult passwords. By the way, if you would be interested in a more in-depth video about how hashing works and how dictionary attacks work, let me know in the comments section, and I will absolutely create a new one, and I will absolutely create one, because I'm kind of interested in this stuff too. Alright guys, I guess that kind of wraps up today's video, and I really hope that you learned something, and I really hope that you enjoyed watching. And all jokes aside, a simple like will really get this video some traction on YouTube, and if you learned something today and would enjoy watching more videos like this, please consider subscribing to my channel, because it will really help me a lot. Even just 1 or 2 subs right now in this stage of the channel, if I can get 1 or 2 subs, that should give me enough motivation to keep making these videos. And if you have something specific that you want to see, leave me a comment, and especially if I made some sort of mistake in this video, don't be afraid to nicely let me know in the comment section down below. Alright, thank you for watching, and I will talk to you. Alright, thank you for watching, and I will see you later. Bye.